there are going to be some triangles where, depending on the information that we're given, if we try to set up law of sines, it's not going to work. So my go-to is always to try to set up law of sines, but then on some triangles, that is not going to work. There's going to be two types in particular where it's not going to work. The law of cosines, the triangle is set up the same way that we have seen before. Capital A, capital B, capital C are your vertices, meaning lowercase a would be here, lowercase b would be here, lowercase c would be here. So it's listed as three separate formulas, but it's really all just kind of one formula. I will also give you this formula on the board whenever we take a quiz or a test on this. Back when we did have a state test for pre-calculus, they did give you a formula sheet, and this is on it. So I don't mind giving you this formula. Actually, law of sines is also on that formula sheet, which I felt like was unnecessary because kids always remembered law of sines pretty well. It wasn't very hard to memorize. This one, actually, I have before given the quiz on this and forgotten to give the kids the formula, and nobody asked for it. Because once we get into it, it's really not that hard to remember this one either. But I'll give it to you if you need it. So what you'll notice about these three formulas, if I've got a lowercase a here, then I've got a b here, c here, bc, and then cosine of capital A. So the ends of this formula have to be the same. The lowercase a here, the capital A here. If you have the lowercase b here, then it's going to be the angle across from it that goes here. Same thing with the C. It really does not matter which side is your B or your C here. Because if I square two things, it makes them both positive, right? I'm adding them together. I can switch the order of addition. So it doesn't matter if I put the B here and the C here, or if I put the C here and the B here. Doesn't matter. Also right here for your BC, it also doesn't matter which one's B and which one's C for that, because you're multiplying, so you could switch the order and it would still be the same. So what's really important is the side you're trying to find, you need the angle across from it to be the cosine of the angle that you're using. And then the other two sides will go in those other spots there. So usually students are pretty good at remembering this, even though it looks like a complicated formula. And one of the most wonderful things about the law of cosines is that there is no ambiguous case for the law of cosines. Cosines must be used when you have two sides and the included angle. So that is going to look like this. If you've got a triangle here, if you have this angle, you would have the two sides that make up that angle. Okay, this is different than angle side. Okay, this is a side angle side situation because that angle is made up of those two sides that are touching. Okay, so a side angle side situation, you're always going to have to use law of cosines. The reason you have to use law of cosines is because you don't, like this angle, you don't have the side across from it. This side, you don't have the angle across from it. And this side, you don't have the angle across from it. So you don't have any pairs. So if you have a situation where you don't have an angle and the side across from it, you can't use law of cosine or law of sines. There is one more situation that you also may use law of cosines for. That would be if you just had all three sides. If you've got side, side, side. That is going to be one you're going to use law of cosines for. Obviously, you can't use law of cosines on that, law of sines on that one either, because you don't have any angles, and you must have an angle in the side across from it for that. Now, once you find one of the missing sides or angles, you can then use law of sines after that because you have that information. Okay, we all right here? All right, so let's look at our first example. You can see I'm not going to be able to set law of sines up. So today your assignment is like yesterday. Today is just going to be a bunch of triangles that's going to be on your assignment. So we're just working on the mechanics of being able to do this. But when we get to the word problems that we're going to do on Thursday, they're all going to be mixed together. So you're going to have to decide, is this the law of sines or is this the law of cosines? In this case, if I look, I don't have the side across from this, I don't have a pair here, and I don't have a pair here. So there's no way that I can do law of sines for this. This is going to be a law of cosines problem, and because I only have this angle right here, I must find the side across from that angle. So we'll be using that formula, which is a squared equals b squared plus c squared minus 2bc cosine of a. I did get that right, didn't I? Was it 2? Yeah. Okay. So when we plug this in, a we don't know, so it's going to be a squared. B and C, it really doesn't matter whether 12 or 15 is B or C, but of course 12 would be B and 15 would be C. But if I switch them, it's not going to matter. You'll get the same answer. So I'll get 12 squared plus 15 squared minus 2 times 12 times 15 cosine of this angle, which is 98. So it looks complicated, but it's really not, because these have to be calculator active. You can't do this without a calculator. Unless, you know, Miss Hendrick was telling me, Miss Hendrick, whenever she was in school, they did not have calculators that would do cosine 98. She had a chart that had the value for cosine of 98. So she had to look up cosine of 98 on her chart and find out that it was 0.1254, and then she had to do all of that work by hand, which is crazy. So another marvel of the past for today, but we just get to type it into the calculator. So you can just type it all in one big string of numbers. Be really careful. One thing I see students do wrong on this is they write that as their answer. That is not their answer. It is the a squared. So that's 0.1023. How do we find the actual answer? We just need to square root that. So if we square root that answer, we will get 20.472. So A is going to equal 20.472. And that's reasonable. Like, it would not make sense for us to have this side be 12, this be 15, and that be 419. So okay, questions? As always, make sure you are in degree mode for these problems. If you have, as long as the calculator doesn't reset, it's just going to stay in degree mode. But if you second plus sign 712 your calculator because you want to clear something out, then it is going to reset it. I would encourage you not to use second plus sign 712 to reset your whole calculator unless you like have something not working that you need to do that for. Some students will do, like, if they want to clear out y equals, they'll just do second, they'll just reset their whole calculator, which will clear out y equals, but is a little. If you want to clear out the home screen, you just clear this out. If you need to clear out the y equals, you just go up here and just clear and enter on those. So it'll clear those out. Sometimes you need to clear out your list, although we won't really need it a whole lot here. But like if you have, you can go to the list. No, that's not where you get stat. Edit. If you need to clear that out, you can just go here and clear and enter. And then clear and enter. So I find it better to like clear things individually out instead of resetting your whole calculator, because sometimes you'll accidentally set yourself back to the gradient mode without realizing you've done it. And if your answers aren't way off, you might not realize you've done it. So Okay. Let's make it smaller so we can. All right, so again, tonight's homework is going to just be triangles, but I like to throw in a few of these application problems so you can get a picture of like how this would work. Car A and B leave the same point at the same time. A travels north on a straight road at 60 miles per hour. B travels 20 degrees south of east on a straight road at 45 miles per hour. After 2 hours, how far apart are the cars? And this means how far apart are they, like as the crow flies, right? Not on the roads that they're on. But so this is an oversimplified problem, but because probably the roads are not perfectly straight for this long of a distance, right? But it kind of gives you an idea of how this could be used to locate different things. You know, sometimes on crime shows they'll have maps and they'll have all this like drawn out, and they're using all this math to figure stuff out. So this is like an oversimplified version of something like that. So if we've got, let's say we've got, here I'm just going to do the X and Y axis. The easiest place to have them start from is the origin. So we've got car A, and car A travels north at 60 miles an hour. So A is right here. For 2 hours, so how far does car A go? 120 miles. So let's say that car A has just robbed a bank. We're going to put one of you guys in the car. Liam likes to wear a ski mask sometimes, so we put him. Liam has robbed a bank. He has taken off on a straight road. He's going 60 miles an hour so as not to be suspicious. If you're speeding off at 120, the cops are going to catch on to you pretty quickly. So he's just flowing with traffic, 60 miles an hour up here. There is a similar car, and the cops think that he is in that car, and they're chasing this car. So car B for 2 whole hours. So they are really confused on what's going on here. So car B travels 20 degrees south of east. So this is north, this is south, this is west, this is east. So when we see 20 degrees south of east, it means the road's main direction is east, but it's 20 degrees below that. So it would be going in like this direction right here. This is our car B. And this angle right here is 20 degrees. And if you go 45 miles an hour for 2 hours, how far will you travel? 90 miles. And so the question is asking how far apart A and B are at. So if the cops have been chasing the wrong car for 2 whole hours, and they have been chasing this car going 45 miles an hour in this direction, but they suddenly realize that really they should be up here. We want to know how far they're going to have to fly. So we'll assume they got the helicopter on this by this point, and the helicopter can just go straight to this other point. And we'll see how fast this has to go. Now, this only works if Liam has stopped. So he has stopped here either to like steal a new car so that they don't know his vehicle, or to get a snack. We're not sure why he is stopped, but he's stopped right here. So we want to know how far the helicopter would have to go to get back to him. So we've got a triangle here. Do I have any of the angles of the triangle? Yes. Yeah, so this right here is a right angle, and we don't have this angle of the triangle, but we can find it really easily, because if this is 20 and this is 90, that's going to be 110 right there. So we need to find side x. So we'll have x squared equals, and then it doesn't matter which one is A or B, the 90 or the 120. It doesn't make a difference. So I'm going to do 90 squared plus 120 squared minus 2 times 90 times 120 cosine of 110. So we'll have 90 squared plus 120 squared minus 2 times 90 times 120 cosine 110. So we get this big number. That is our x squared to 29,887.6351, but we've got to take the square root of that. So square root of this answer is going to be 172.880 miles. How fast do we think a helicopter can go? Not fast enough for the Avalon. So yeah, around 150, 173. 2-engine helicopter, 185. So 257 for whatever the world record holder. Yeah. Yeah. So depending on the level of severity of this crime, if it's just a standard bank robbery, I think we're okay. If we got high level military on this, they might can catch him. He's got about an hour before they're going to be there. Of course, they can radio ahead, of course, and get somebody up. Yeah. I think I'd be about 4 stars. Yeah. So now, just as a note, because I think this is cool. So let's say the same situation happens, but Liam has not stopped. He is still traveling, right? So we're not going to do that problem, although I'm really interested and I think I might need to go try to do that problem sometime just for fun. If Liam has not stopped, then the side of this triangle is not always 120. It's 120 right at that moment when they realize, uh-oh, I've got to go over here. But that side of that triangle is getting longer because he's still driving. So that changes a lot of things about the problem. The setup would still be the same because the 90 would not change. That would, this would be the place where they turned around, so that 90 would be the same. But the 120 would be changing. So would the x, because the further he drives, this would also change. So that takes this and turns this from a pre-calculus problem that we can do right now, where Liam has stopped eating his snack for a minute to rest up after his bank robbery. Where if Liam is still fleeing, that takes it from a pre-calculus problem to a calculus problem. You can use calculus to find that. Because what's going to happen is this value is going to be changing, so we would do something called a derivative that you don't know about that would tell us the way those rates are changing, and you could actually, like, if you knew how fast the helicopter could fly, you could figure out when he could catch that. But we couldn't do that with pre-calculus math because it would be, you'd have multiple variables that were changing in that case. So that's kind of one of the differences between pre-calculus sort of stuff and calculus stuff. Calculus deals with things that can be changing over time. So we can have like dynamic situations instead of just like, here's this triangle, solve it. So it's kind of a cool application of that. But I think I need to go try to solve sometime. I think I need to go try to do that. But I won't do it here because it's definitely not related to what we're doing. All right, we're going to do just one more problem here. We need to do one where we have all of the sides of a triangle. So we're supposed to solve this triangle, XYZ, and we are given all of the sides of the triangle. So if I draw this here, this is my shortest side, it's 14, so I'll call this X. Then we've got 19 is next, so I'll call this right here Y. And then 22 is the longest, so I'll call this Z. So obviously you cannot solve this using law of sines because you don't have any of the angles. You must have at least one angle to be able to solve this using law of sines. So you've got to use cosines for this. It's going to be a little bit harder to solve, but you still do not have ambiguous case for this because the only types of triangles that could have ambiguous case are angle side side, and those only happen with law of sines. So we can pick any of these angles to solve for first. It doesn't matter which one we want to solve for first. So Lily, which one do you want to pick, X, Y, or Z? Y. Okay, so we're going to choose Y first, and we're just choosing that because Lily said so. It really doesn't matter which one you pick first. There's not one that's easier to do than the others. So if we're going to do Y, we need to look at the side across from Y, which is 19. So we'll have 19 squared equals, it doesn't matter which one you put first, X or Z, so 14 squared plus 22 squared minus 2 times 14 times 22, and then we'll have cosine of Y here. So that cosine Y must go on this end because that's the one we've decided to look for first. The side across from it needs to be the one over here. So this is going to take a little more work to solve because you're actually having to solve for a Y over here. Whereas on the other problem, we could just type like that big long string of stuff into our calculator. So we're still going to rely on our calculator. Let me do that for a lot of this, but we'll have to do a few more steps. So 19 squared is 361. Some of this we can do together. 14 squared plus 22 squared, we can do that together. It's going to be 680. So this part right here is 680. We cannot do that whole string of numbers together because 2 times 14 times 22 is multiplied by cosine Y. So we can do this 2 times 14 times 22, but we can't put it together with that 14 squared and the 22. So this stuff right here is 616 cosine Y. It feels like we should be able to do 680 minus 616, but we cannot because this 616 is multiplied by cosine Y, so they are not like terms. So that's why we can't put those two numbers together. So what we've got to do here is subtract the 680. So we're going to get negative 319 equals negative 616 cosine of Y. Then we're going to divide that negative 616. And so we get 0.517857. Keep that number in your calculator. Equals cosine Y. And our last step on this is to inverse cosine that. So if we do inverse cosine of that answer, we will get 58.811 degrees for our Y. I would suggest storing this because we're going to have to use this number again. I don't know if it's a good idea to store it for Y because that might mess some of your equations up. So I'm going to store it as A. I generally try to avoid storing things as X or Y because those are in the equation. And some of the calculators can handle it whenever you do that, but some of the older ones don't do it right. It messes up your graphing if you graph, so we don't graph a lot on this. But. All right, so we found y, 58.811. So that gives us one of our angles. You have options on finding your other angles. You could do law of cosines again, just like I did. If you prefer it, go right ahead. But since you have one of the angles now, you could use law of sines. So if we want to use law of sines, I think that's what I will do. Sine of 58.11 over 19 has to be used. And then you can find x or z. It does not matter. Let's see. Maggie, which one do you want to find, x or z? X. So if we want to find x, we'll have sine of x over the side across from it, which is 14. And so we are just, this is an angle side-side situation. The good news is you can't really have an ambiguous case, but you might need to check both. There might be only like one of the two answers that would work. You shouldn't see ambiguous case very often with this. And it's not really because you could figure it out because you have all the sides there. So 14 sine 58.811 degrees by 19 sine x equals 14 sine by 19. It's going to give us 0.6303. And we will do sine inverse. So, sine inverse of that answer is going to be 39.076 degrees. In general, if this works, it should be the right answer. There is a chance that you might do a problem where this doesn't work for the triangle. So then you would need to do 180 minus this number and use that other number instead. So, but this works. So if what you get works, just use it. That's your best answer. And then for the last one, for z, that's going to be the easiest one to find now because we're just going to do 180 minus the 58.811 minus the 39.076 degrees. That is going to give us 82.113. Okay, questions?